In this video, we're going to use our exponent rules with variables to simplify a few expressions. Again, notice that it says simplify, not solve. We're not solving anything. There's no equal signs that we can find a value for, so we're just going to simplify. Now, when we have these, we have to remember that these properties work when the bases are the same. So I can't combine the A's and the B's together, but I can use my power of a power rule. All right, what is it? Power of a power property. This is going to be A to the 2 times 3, which is 6, over B to the negative 3 times 3, which is the negative 9th. Well, I don't want a negative exponent. I can't have a negative exponent to be fully simplified. So if I have a negative exponent, I just bring it to the other side of the fraction, so that B was to the negative 9th in the bottom of the fraction. I bring it to the top of the fraction and change the exponent from negative to positive, and I'm done. I need to remember and always think about things being in top and bottom of a fraction anytime I see a negative exponent, okay? So in number 8 here, this negative y is going to mess with somebody. The y is being squared, the negative is not. If the negative was being squared, we would have had to have parentheses around all of negative y. So this is negative y squared to the 5th. That's like a negative 1. I'll put that back as a red negative 1. So this first set of parentheses is actually like negative 1 to the 5th times y to the 10th, where I get y squared to the 5th. 2 times 5 is 10. Then I still have times y squared times y to the negative 12th. Okay, if I just did that first set of parentheses. Now, negative 1 to the 5th, I can quickly identify if that's negative 1 or positive 1 by saying, well, it's an odd exponent, so I'm going to go back to negative. But if it had been a negative 2 to the 5th, that requires a little bit more thinking and evaluating of the number. But here, I'm going to be able to say this is negative 1 y to the 10th times y squared times 1 over y to the 12th is how I personally am going to do this. There's multiple routes because all we're doing with these properties is adjusting our puzzle pieces. So if we think of this as a giant puzzle that we have to do, it doesn't matter if I do the corner pieces first, the edge pieces first, or the middle pieces first. What matters is that I put them all together to make whatever picture is on the puzzle. I chose to rotate them this way so that I'm going to end up with negative 1 y to the 12th on top, y to the 12th on bottom. This y to the 12th is using my product of powers property. I'm multiplying two things together with the same base, so I add their exponents. 10 plus 2 is 12. Then, because this y to the 12th is now on the bottom, because it had been a negative 12th on the top, that's where this piece comes from, and I get to use my quotient of powers property, which is essentially just dividing those two. They're identical. They all cancel out. I'm left with negative 1 times 1, which is just plain old negative 1. Okay? You could have just added all those things together using the product of powers property. Negative 1 times y to the 10 plus 2 plus negative 12, which becomes y to the 0, and anything to the 0 is 1. Negative 1 times 1, still negative 1. You've got options. Okay, and then this third one here, there's a negative 1 as an exponent and part of the bottom. When I say part of the bottom, that negative 1 is stuck with just the s. So what I'm going to start by doing is trying to figure out how to take care of the parentheses with the cubed. So that r currently on the bottom is to the first. So 1 to the times 3, r to the first to the third becomes r to the third. Then I'm going to have s to the negative 3. Because again, s to the negative 1 to the 3, negative 1 times 3 is negative 1. Now, how that matters for me, I'm going to have, that's what the top was originally, but this s cubed to the negative 3, I should say, is going to come up to the top of the fraction and become a positive 3. Now there's some behind the scenes stuff that I'm kind of glazing over because it's what was covered in Algebra 1. And if you're like, this does not make sense, you're moving too fast, please, please, please ask me some questions in class. I can slow it down and go through a more in-depth description. But if I'm looking at just the R part here, I have more R's in the bottom, so I'm going to just put an R in the bottom. There is 1 on top, 3 on bottom, which means there's 2 more on bottom. That's technically using my quotient of powers property. And then I have all of my S's on top. 2 and 3 make 5. I add those exponents together because I'm using my product of powers property. So I get S to the 5th over R squared. Again, if you have any questions about this, please, please, please ask in class or a win session or whenever you see me and get a chance. Have a great day, everybody.